So I'm Marco Arrigoni with Coherent. I would like to start my presentation giving you a little flavor of Coherent Corporation, or the new Coherent Corporation, which is the result of II-VI acquisition of Coherent Inc. At this moment, Coherent Corporation has 28,000 employees in many parts of the world. We have also, basically, we are divided in three segments: in networking, materials, and laser sources. Our participation to the quantum market is historically connected to laser sources, and you see on the back a few examples of that. We made the lasers, the titanium sapphire and dye laser that powered the first experiment in cold atoms. We make very narrow linewidth laser used for optical trapping, and we make moduloc lasers that are used to address certain systems like ytterbium ion platform. We also make VCSEL that are used actually in the CSAC, to give you an idea. Now, what I want to show now is something that we are developing, and we had as a technology, proprietary technology, for a number of years. And I want to focus on two aspects here. The first one is what we call optically pumped semiconductor platforms. And you see here a couple of examples of the coverage. This is a technology that allows to cover by design a broad number of wavelengths by designing the semiconductor chip. And you see a flavor of that behind me with the coverage of this product in terms of infrared and visible wavelengths. Now, the beauty of this platform is that it can be expanded by tailoring different types of semiconductor platforms. And you see here an example of how we are going to expand the range of wavelengths available and also the relative power level. So this provides a step up in terms of power and wavelength coverage. The second aspect is that the combination of Coherent Inc. and II-VI Corporation offers an incredibly broad spectrum of semiconductor laser technology. You see here some examples: tapered amplifiers, narrow linewidth diodes, narrow linewidth and linewidth narrowing devices, and a variety of processes to build these type of structures in a variety of materials. So just want to give a flavor of the first technology I mentioned, which is the optically pumped semiconductor laser. This is actually not a product. It's something that we demonstrated and we published at Photonics West of last year. It's a 15-watt device operating as a laser guide star at a wavelength of 589 nanometers. You see how compact it is, the size of a shoebox, and with a line width of 18 megahertz, without any effort on our part to narrow the line width. So it was just a very first step. So what excites us as a company looking forward? Our observation is that there is a wide number of atomic systems. If you look, for example, at schemes of atoms and ions used for quantum computing, and this is too much. There is a need for some pruning, and some pruning of the number of systems and the number of required wavelength also will result in a cost reduction, in a better standardization, and also in a higher level of reliability and consistency. At least this is our assumption. And also, this means that it will favor actually wider adoptions in the photonic industry. So what is at this point, what excites us, what we would like to do moving forward? We know that we master compelling material platforms like the one that I showed you before. Also, we will expand the platforms and the range of wavelengths and power available as the ecosystems matures with respect to the large number of systems that are proposed at this point. And last but not least, we also look for partnership and synergies in some aspect where we think that it would be beneficial for us and also our partner. A couple of examples I want to give is line width management to produce extremely narrow line width laser, and also on the side of photonics integration, where currently we are not a player in this industry. And with this, I just end my presentation, maybe with some time left even, and I thank you very much.